All right, guys. Let's get things going on here. Guys, at the end of the day, I wonder how many times, and some of you may have already done this, how many times I go, or at the end of the day, or in a nutshell, or I know I repeat a lot of stuff, and sorry. So anyway, guys, in a nutshell, our betas that we have in simple linear regression and multiple regression are very, very similar to the betas that we get in logistic regression. At the end of the day, there you go. They provide a means of predicting our y, which in logistic regression is the probability a case falls in a certain category. So, so logistic regression coefficients are used just like those in multiple regression. We use them to predict y, which is the probability a case falls in a certain category. All right. Now, it's a little tougher than that, but you know, let's just make it happen. So, guys, again, I want to contrast this with simple regression. In a simple regression, a beta tells us the change in the outcome resulting in 1 unit change in the predictor variable. But it's much easier to interpret there because our outcome is something that's measured on a continuous scale, you know, like GPA or ACT or you know, feelings about whatever it may be. So, you know, a 1 unit increase in the predictor, whatever the coefficient number is, it tells us the change that we can expect in the dependent variable while controlling for everything else in our model. It gets a little tougher for logistic regression. Okay, so for logistic regression, the beta represents, let's say, the change in the log of y with 1 unit increase in a predictor variable. Yeah, you got to think about this. What, for example, if you've got a beta that's 2, we say controlling for everything, you know, all the other predictor models, or I'm sorry, predictor variables in our model, increasing, let's say this was beta 2 for x2, whatever it may be, increasing the second variable by 1 unit creates an increase of 2 in the log of y. Well, that's a little strange, but it turns out we have ways that we can address that make it not so strange. Okay, so again, taking this, delving in just a little bit deeper. For simple linear regression, again, let's think what we did in evaluating the individual coefficients. We would calculate a test statistic. The underlying probability distribution was the t-distribution. From there, we could calculate a p-value, and from there, we usually created a confidence interval. It doesn't have to be a 95% confidence interval, but it usually was. Well, guys, what happens in logistic regression? Pretty much the same stuff. The only difference, it has just different names, okay? For logistic regression, we actually end up with a z-statistic, which is closely related to something we call a WALD, W-A-L-D statistics, which I may talk about later. I don't know how far we're going to get in this video. But the z-statistic follows normal distribution, mean 0, standard deviation 1, so no degrees of freedom that we have to worry about. And you know, just like in simple linear regression, we just test that beta is equal to 0 and beta is not equal to 0. So the results of the significance test tells us if the predictor is significantly different than 0. All right, so if you know, so if all this is true, then we can assume that the I should say, if we have statistical significance, we can assume that the predictor is contributing significantly, or at least making a significant contribution in predicting the outcome. Okay, so guys, getting really formal, we can dive in and take a look at the outcome, so, or at the output. So you know, let's just go ahead and do that. Let's get out of this, and I kept R up, and even though I have N there, I can go back up and you know, again, what's going on here? This stuff is the model summary, and obviously, if we want to look at the summary of the coefficients, we can look right here. So we can see the tutor. Notice it's got yes, which we set tutor 0, no, as the baseline. So this tells us that 1 unit increase in tutor, which goes from 0, was 0 to 1, no to yes, and that's what R is trying to tell us here. We set the baseline as 0. That the estimate is 1.28. We have a standard error that seems reasonable. It's not highly inflated, so I don't get into any concerns we talked about in one of the previous videos. We get a z-value of 3.074, and we get a p-value of 0.00212. So, gang, what we could do here is we can say that tutor is a significant predictor of success, and our beta was equal to, I think that was, what was it, 123? 1.23, wasn't it? Guys, I forget. And I shouldn't forget. Yeah, 1.23, 3.0. Okay, cool. All right, so let's get this where you can see it. So beta is 1.23. Our Z was 3.0.07 or 3.70. That, buddy, keep me honest here. I think it's 3.07, but if it's 3.70, let me know. I truly appreciate when you let me know those things. Okay, so tutor is a significant predictor of success. B equal 1.23. That's our beta. In isolation of everything else, it says as we increase from no tutor to a tutor or attending tutoring sessions, the log of y increases 1.23. Now, what the hell's the log of y? That's $1 million question, isn't it? And it's creates difficulty in making meaningful interpretations of logistic regression results. But turns out there's a really cool feature that we can there's something we can do that makes it well, it gets this log of y back into odds and odds ratios. All right, gang. Similar to R, I want to kind of jump out now back to a model summary and examine R that we talked about in one of the previous videos. And we saw one R, or at least I intended to show you this. Actually, I'm starting to wonder if I did show you this. That can be calculated this way. Okay? And I want to show you this calculation. I typically don't report this value, but there's a value called Hosmer-Lemeshow, or Lemeshow. I never did know how to pronounce that. That I do think is important to present for an overall model analysis. And I want to show you something, and this is the reason I'm showing you this. So, gang, in our z-square was 3.074. So we need to square that. And our degrees of freedom, we had, what, 1 degree of freedom, right? Yeah. And our base of the -2 log likelihood, I wrote down as 154.08. So guys, we end up at the end of the day, there we go, end of the day again at 0.22. That may be something you guys could do your master's thesis on, is how many times does Darbro say, end of the day, nutshell, so on and so forth. Guys, the one I want you to have on your immediate radar is the Hosmer-Lemeshow. And I think the notation I used was just R squared HL. And oh shoot, I don't remember how to do this. Let's see, R squared was the, okay, yeah. It turns out it was the model chi-square, so the change in the chi-square statistic, looking at the change in the deviance minus the 2 log likelihood of our base. So our model chi-square was 9.93. I had these numbers written down, but I didn't have that written down. And then this was 154.08. And this tells us 0.064. Now, what I want you to understand is that, you know, put on your radar that you know, 0.064 squared doesn't give you 0.22. These are just different measures. Guys, one more thing I'd like for you to again put in your notes and have in your logistic regression terminology. Something called a walled statistic. We're going to run into this from time to time. In fact, most I know SPSS and SAS, their logistic regression output includes the walled statistic. But anyway, the walled statistic, if we just take our z value and we square it, this is equal to the walled. And this thing follows a chi-square distribution with degrees of freedom, the difference in the degrees of freedom for the deviances. All right, gang, let's get into some good stuff. All right, let's get into something that we talked a lot about back in log linear analysis, these odds ratios. Okay, I'm going to show you two ways to find these. They provide excellent interpretation of our betas. We can get these things back in terms of odds and odds ratios and ultimately probabilities, and get it out of this whole predicting log of y, which is clearly confusing. Now, first of all, if we think about the probability of determining a success, and the first thing I want to do this for is I want to do it for my baseline as none for Friday tutors. Now guys, remember the probability of success. We take 1 over 1 plus e to the negative b0 plus b1 x1. Well, for our problem here, we run into the situation where we have 1 over 1 plus e to the negative. Now, guys, our b0 is negative. Well, let me double check this. This is getting crunch time, and I can't. I think it was negative 0.288. Yeah. Yeah. Okay. So negative 0.288. All right. Cool. So we have negative 0.288 plus our beta 1, which was 1.23, times 0, because we are looking at none for Friday tutors, and that was coded as 0. I already went ahead and did this. I get 0.428 as the probability of success for a student who did not attend the Friday session. All right, so let's keep this in mind. All right, so the next thing I want to do is also look at the probability of success. For what? Well, you should know this. This is, well, I take that back. I don't want to do that just yet. Let's do this first. Let's do the probability of not success when x1 is equal to 0. And again, don't forget, this is just none in terms of Friday tutor. Okay, so this is really going to be super easy to calculate. Was that 4.428? So it looks like it's 0.5. Okay, 0.428, so 0.572. Right. All right. So now what I want to do is I want to look at the odds of the odds ratio. Actually, it's not the odds ratio; it's just the odds. And I want to look at this in terms of success. So I'm going to have 0.428 over 0.527. In this situation, I get 0.748. Guys, this is not the odds ratio. I'm thinking ahead, speaking when I should be thinking about what I'm doing, not thinking about what I'm going to be doing. So this is the odds of So let's see, the 0.572, the odds of success to not success. All right? Now, what I want to do next is I want to do this again, but obviously what I want to do now is I want to examine this when x1 is equal to 1, where we actually did have the student attending the tutor session. So guys, that's going to be easy to do, all right? So get this. So now we'll increase our predictor by 1 unit. All right, so probability of success.